Okay, today we are gonna take a look at what's inside the generic SLA 3D printer. This is the model we are looking at, Frozen Sonic Mighty 4K. This is the user interface display. It's a resistive touch screen. You can see here. Resistive touchscreen connector and a backlight. This is the cooling fan for the LED array. And here's the label if anyone wanna read it. Here it is. Here is the LED array. This is just power and everything. The LED control circuitry is all under there. Here's the you can see the tiny UV LED here. There's some current emitting resistors, and there's some SMD package. I think it looks like a transistor, but I think it is some sort of linear current regulator, and there's quite a lot of them. One for each LED, in fact. Which I think is quite an overkill for this application. Because this is just near UV LED, not UVC. It's really not that sensitive. It's like a normal blue LED. And here's the lens. Judging by the lens, you can tell it's not UVC because it's just plastic lens. If it's UVC, would great with plastic. Here's the Z-axis calibration sensor, and here's a stepper motor for the Z-axis, of course, and here's the monochrome LCD for the X and Y in the front. Just sticky taped down. Here's the sliding rail and the ball screw for the Z. This thing is very heavy, it's all solid aluminum. And of course, this one is the adapter board that connects to the display. And here's the main board. Of course, all the magic is in software. You can see this is Endogic. This one is FPGA. I assume it's for driving the display because you can see all the tracks go from the display to the IC here. This is level shifter to drive the user interface. This connects to user interface LCD. This I think is level shifter. So buzzer. This under heatsink is the stepper motor driver for the Z-axis. Here's some power conversion things. This is SPI NOR flash for the microcontroller. On the back it's STM32. This is a DRAM to store the image because the display is 4K. It's quite out of date, huh? The display, I assume, has no grayscale, only on and off. So it's actually not and it's only monochrome, so it's not as much as you expect on a normal 4K monitor or TV, for example. Those 1 pixel will have each color 8 bit of data, and also there's RGB, so there are more than this one. So a microcontroller and FPGA can handle it perfectly. And here you can also see the reason why I took this apart. The power connector is broken. I just need to solder it back. That's it for this video. This is really quite a lot simpler than what you'll find in a FDM 3D printer, for example. The mechanical part is just this 1D screw, and everything else magic is happening in the software. That's it. Thank you for watching. Bye.